Bismillahirrahmanirrahim. Assalamu alaikum. Today we are into part 1 A matrices, which is 3 minus 1, 2 and 1, and we find its inverse, and inverse is A inverse adjoint A over A determinant. And when we find the inverse of matrix, we first calculate its determinant, which is if singular, then we solve it, and if not singular, then we cannot solve it. Now we find the determinant of A. 3 minus 1, 2 and 1. 3 ones are 3, minus 2 multiplied by minus 1 is equal to minus 2 is equal to 3 minus multiplied by minus plus 2 is equal to 5, which is not equal to 0. So we can solve it further. Adjoint A is equal to adjoint A matrix is 3 minus 1, 2, 1. And when we find the adjoint of this matrix, we have 1, 3, minus 2 and 1. This is the adjoint of A. And E inverse is equal to adjoint A over A determinant. Put the values of adjoint A and A determinant, we find it the answer. Adjoint A is 1, 1, minus 2 and 3 over A determinant is equal to 5, and we write it 1 over 5, 1, 1, minus 2 and 3, and the answer is 1 over 5, 1 over 5, minus 2 over 5 and 3 over 5, and it is the inverse of the A, which is part 1. And now we solve part 2. We say it B matrix, which is minus 2, 3, minus 4 and 5. We find the inverse B, which is adjoint B over B determinant. First we find the determinant of B, which is minus 2, 3, minus 4 and 5. Multiply minus 2 with 5 is minus 10, minus 4 multiplied by 3 is equal to minus 12. Minus 10 plus 12 is equal to 2, which is not equal to 0. Now we can find its inverse. And first we will find adjoint B. Adjoint B is equal to B matrix is minus 2, 3, minus 4 and 5. And adjoint is 5, minus 2, 4 and minus 3. Now B inverse is equal to adjoint B over B determinant. Adjoint B is here 5, minus 3, 4 and minus 2. And B determinant is 2. And we write it 1 over 2, 5, minus 3, 4, minus 2. And get the answer 5 over 2, minus 3 over 2, 4 over 2 minus 2 over 2. Now we can simplify it. 5 over 2 minus 3 over 2. 4 divided by 2 is equal to 2, and minus 2 divided by 2 is equal to minus 1. And it is the simplified form of determinant matrices B. Now we find its third part, inverse of C. Third part is we write it C. 2 iota, 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 and minus iota. We here find C inverse, which is adjoint C over C determinant. And we know, first we find the determinant of C. 2 iota, 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 minus iota. Here 2 iota multiplied by minus iota is equal to minus 2 iota, and minus iota multiplied by iota is equal to iota square. Here is also square. Minus 2, and we know that iota square is equal to minus 1. Minus, and here is also minus 1 is equal to minus multiplied by minus plus 2. This minus multiplied by minus plus 1 is equal to 3, which is not equal to 0. And we can solve it further. We first adjoint C is equal to adjoint 2 iota, 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 minus iota. And here we find it, get minus iota, 2 iota, minus iota, and minus iota. This is the adjoint of C. And C inverse is equal to adjoint C over C determinant. Adjoint C is minus iota, minus iota, minus iota, and 2 iota, divided by C determinant is 3. And we write it 1 over 3 minus iota, minus iota, minus iota, 2 iota. And we write it also minus iota over 3, minus iota over 3, minus iota over 3, 2 iota over 3. And this is the C inverse. And the fourth part is we write it D matrix, and which is 2, 1, 6, 3. And we find the D inverse is equal to adjoint D over D determinant. D determinant is equal to 2, 1, 6, 3 is equal to 2 3s are 6, minus 6 1s are 6. 6 minus 6 is equal to 0. And 6 minus 6 is 0, and it is a non-singular. And we cannot find its inverse. So the answer is we can't find inverse because D is a non-singular matrix. Okay.